And he's here. Hello, Dr. Freeze. Good morning.
Hi, Sarah.
How are you doing this morning?
Well, I'm doing just fine. How are you doing?
I'm doing very well.
Well, good. How's it going so far?
Good. We've raised over $1,000 for CDG care so far in the last 2 hours.
Oh my gosh, that's fantastic. You are on a roll, I gotta tell you.
Yeah. Yeah, so we currently have over 25 people in the audience waiting to hear you talk about glycobiology and CDGs.
Oh boy, I better have the right answers then, huh?
I'm pretty sure you're one of the only people with the answers.
Are you having fun?
Yes, I'm having a lot of fun. I'm playing a game while we do this from beginning to end to beat it.
Okay.
Yeah.
So what should we do here?
Well, I already wrote out some questions that I can ask you to get the ball rolling, and then I have it set
Okay.
up where the audience can ask questions as well.
Okay, sounds good.
Yeah. Let me just pull them up. What page are they on? Here they are. So, what sparked your interest in glycobiology? Could you tell us a bit about yourself and your career?
Oh, gee. Well, glycobiology goes back a long way. I was a graduate student, and this was at the University of California in San Diego. I was a graduate student, and I began working on some things that had to do with sugars, and this was in a thing called a slime mold. And, you know, probably the two worst words in the English language, right? Hooking them up together for your thesis project. And anyway, no one had sort of worked out what was going on with certain aspects of this, as it's called, social amoeba. And social amoeba just means that it's, it's one of these things that, oh gosh, I'm going to turn this off so it doesn't make so much noise.
Okay.
Okay, there we go. So a social amoeba that gets together when it's running out of food, and it knows that it becomes an organism. So it was very exciting to do all this work, and a good friend of mine was doing some glycosylation work, and that got me interested. And then a few other people, because I was doing that, came to me, and they were working on some rare lysosomal storage disorders. And those are disorders that are sort of the other side of glycosylation, which means that you don't break things down well enough and they accumulate. They cause a really pretty awful set of disorders. So that brought me into it. And then I think, the other thing was that when I saw there were patients who had many other kinds of glycosylation abnormalities, then I thought, well, this is something that maybe I could make a difference in the world in if I did this.
Yeah.
So I could apply glycobiology, which isn't really very well known among even most basic scientists, and certainly not in physicians. I thought maybe I could do something worthwhile to walk in and see what I could do, see if I could help out.
So you mentioned there's glycosylation disorders and lysosomal storage disorders. Could you explain a bit more about the difference between those for the audience?
Sure. So a glycosylation disorder means that you're trying to put things together that involve sugars, not energy sugars, but other sugars that are attached on to proteins and to lipids. And it's a very complicated process. There's hundreds of different genes that are involved in doing this. And if you have a mistake or a series of mistakes in one of those genes, it can really cause a serious problem. On the other hand, a lysosomal storage disorder is a mistake in being able to break down those accumulated sugars. So the body is always turning things over, which means that you make them and you break them down. I mean, you think about when you get a cut, you have a little bleeding, that stops, you have a scab, eventually the scab goes away. Well, that's because things are not only being made, but they're being broken down. And what happens in these glycosylation lysosomal storage disorders is that the breakdown is stalled at one particular point. So glycosylation disorders are making things and they can be stalled, or the lysosomal storage disorders don't break down things that they should, and that accumulates materials. Is that helpful?
Yes. Yeah. So with glycosylation disorders, what organs and systems are usually affected the most by a disorder like this?
For lysosomal storage disorders?
For glycosylation disorders.
For glycosylation disorders. Oh, well, that's something that now even requires a little bit more probe into broader biology. And it turns out that every organism in the world requires glycosylation to live. So every organism needs to activate and use these sugars to make things called glycoproteins. And what happens is that we, as humans, have inherited all of the ability to make these sugar chains, put them onto proteins, but we do that in every cell of the body. So then, with all of these cells making these glycoproteins, it becomes important to do enough work in those organs and those systems that have the greatest demands. So it turns out that the neurological system, which includes, of course, control of intentional movements, walking, all of the things that we might associate with seizures. In other words, when things are not going well, intellectual development. So all of those things can be affected by glycosylation disorders, but it's not limited to that. Because, as I said, every cell and every organ is doing glycosylation. And so those organs that have the biggest demand, if you will, organs like the liver, they can be affected. Blood proteins that are produced by the liver may be inefficiently made, and so you will have problems of coagulation. The other issue can be just growth, because some of the proteins that are required to regulate and allow us to grow are all glycosylated. So again, if you mess up the glycosylation of those proteins, then they don't work as well as they should. And so every organ system can be affected, but those are the ones that are probably primarily hit.
Yes. And someone in the chat asked, does this have any relationship to the growth of tumors, growth without breakdown? Is there any relationship between glycosylation disorders and tumors?
Yeah, interesting that you bring that up. If you look at all of the different kinds of tumors, all the different kinds of cancer, they have one thing in common. Even though they can be very different tumors, they have one thing in common, and that's that they change their glycosylation. Now, they don't all change it in the same way. Different kinds of cells will change different ways of making their glycoproteins, but that's a very common feature. So it's something that, in fact, has been targeted as a potential way to control some tumors. And the reason is because that change in glycosylation can produce what's called a biomarker. And a biomarker is a way that we can look at what's happening in a particular tumor in an individual. And we can see, aha, when this biomarker, this carbohydrate, this glycoprotein increases, that's a bad sign for some tumors. So what you're able to do in some cases is actually to make a therapy that targets that abnormal glycoprotein, and you may be able to, in some ways, treat tumors that way. So yes, it's together, although a different kind of perspective for glycosylation and tumor growth.
Interesting. Yeah. So, have there been any recent breakthroughs that you can tell the audience about? Anything interesting that's been found out?
You mean in CDG?
Yes.
Yeah. Well, I think one of the biggest surprises has come along in the last couple of years. And this is by doing some really basic science. This guy, Ethan Perlstein, did a wonderful study. And, just thinking about it from the outside and at the beginning, I wasn't sure anything much would come of it. But what he did was to say, look, I can make mutations that mimic what we have in CDG. I can make mutations in those genes in fruit flies. I can do it in worms such as C. elegans. You can do it in yeast. And then he said, okay, this has bad effects for all those. Then he did another thing, which was to try giving every known drug. Now there's, a few thousand of those. Mm-hmm. So he tried to see if any drug, could rescue the maladies that hit those different organisms. And what he found, truly amazing, was that it's called, get ready for this, take notes, an aldose reductase inhibitor.
Aldose reductase inhibitor, yeah.
Okay, and that means that this molecule will control how much flow of a certain kind of sugar would go into any of a number of different pathways. So sort of think of yourself if you're on a freeway, let's say, and you see that there is traffic, accumulating in front of you. Well, if you have a nice map, you can figure out, you can take a little side route and you can get around it. And so this is what this aldose reductase inhibitor has been able to do, is it looks like in some way it's redirecting some of the sugars that go into glycoproteins. It's redirecting how they're used and how they may influence the deficiency of enzymes. And this was in the disorder PMM2 CDG.
Yes.
And that's the one that's actually most common. So, I mean, this is really interesting. And it should begin to yield, in the not distant future, some real clinical trials. And that is really exciting.
Yeah, because someone in the chat just asked, I'd like to know about the current available treatments for CDGs and what a hypothetical cure for something such as Pig A CDG would look like.
Well, so let's back up another step and go back to the basic science. As I said, glycosylation is pretty complicated, and there are hundreds of different genes that are involved in doing glycosylation. And right now, we think there are about 160 different kinds of CDG. So a therapy that you might use for one is not necessarily going to work for another. Okay? And if we look at the kinds of things that are out there right now, most of the treatments, aside from this aldose reductase inhibitor, most of the treatments out there that we can see sort of promising effects on very, very small populations and in doing the basic science for it is actually from sugars, just simple sugars, but not like the kind you'd get out of a sugar pack or, in your 5-pound sack of sugar that you buy down at the store. These are special sugars that can go into glycoproteins. And so what happens is in disorders like PGM1, you can use galactose to treat some of those patients. Those clinical trials are starting to move forward. But of course, the FDA has a lot on their plate at the moment, and they're trying to deal with lots of different complexities. So we're not exactly there yet. Another one is mannose that can be used for treating phosphomannose or MPI CDG. And we were the first to try this. And if you want to know a little history, I'll pick that up later. But yes. It was, I'll tell you now if you want to hear it.
Yeah, we'd love to know more.
Okay. So before any of the causes of these CDGs were known, we had done an experiment in the lab where we used patient cells. We didn't know what was wrong with the patient. We knew clinically what was wrong, but we didn't know the molecular basis. And so we noticed that the utilization of this sugar called mannose, which is really an important sugar for N-glycosylation that's involved in PMM2, although we didn't know that's what the defect was, we saw that there was a problem with mannose, and we used this really simple-minded idea. Well, maybe there's just not enough mannose. So let's just add some mannose to the culture medium and see if we can improve the glycosylation in those cells. And you know what happened? It improved.
Wow.
And then we thought, wow, wouldn't it be great if you could take the same approach, feeding this simple sugar to patients? Maybe it would help them. So we lined up, got permission from the FDA to do this because there had never been any real studies done in the US or really anywhere for looking at how mannose might be handled by people. There was one study one time that looked at a single individual, and they took some mannose and they got diarrhea. That was it. That's all we knew. So we had permission to do this. So all the people from my lab lined up over 2 weekends, and we went down into our conference room, stayed there the whole time through the weekends, and drank mannose. We had different doses, we had different repetition times, but anyway, over those 2 weekends, we were able to see that mannose could be taken up and it could be used in the body. We didn't know exactly how, but based on that, we said, you know, God, this is really interesting. Well, somebody saw our paper and had a patient, and they said, look, this patient, who at the time we didn't know what was wrong, doesn't look like the typical CDG patient. This little boy is not growing well. He's got a thing called protein losing neuropathy. He's always low energy. He just can't quite pull it together. But intellectually, he was okay, and he didn't have real neurological symptoms. And the doc said, we saw your paper. Can we try some mannose? I said, well, go ahead. We're not sure what's wrong, but go ahead and try that mannose. Let's see what happens. And miracle of miracles, the boy got better. He improved. He gained weight. He was stable. His blood proteins began to normalize. Little biomarkers that we look at all became normal.
Wow.
And I just thought this had to be some sort of a coincidence. And so this little boy was in Germany, and I just got married. And so my wife and I made a trip from Venice, where we were in our honeymoon, to Munich, where this little boy was. And we could see that he was in great shape. I even have a picture of him getting into his mannose bottle. Anyway, at that point, I remembered an experiment we did on this little boy's cells back in the lab. And the experiment directed us toward one particular enzyme, phosphomannose isomerase. And I wasn't in the lab at the time, but other people were then able to confirm that that was the problem with this little boy. So we were able to treat him with mannose. And I believe he's probably now in his 20s. He's probably still on mannose. We found an American patient. She's was put on mannose very early on once we figured out what was wrong with her. And now she's in her 2nd or 3rd year of vet school.
Nice.
So anyway, that was helpful. And there's another sugar called fucose that we had used for another kind of glycosylation deficiency that involves a lack of this sugar. So we're looking at that. There is another kind of disorder in glycosylation that is caused by defects in this enzyme called CAD. Now, I won't go into everything it does, but we could see that it affected glycosylation. And what we can do is to provide just a little bit of this material, this precursor, this molecule called uridine. And we have this most beautiful video. I just marvel every time I see it, of seeing this little girl, Audrey, stretched out in bed, not able to do anything, no intentional movement. She has no speech. She can't move in any good way. She's confined to her bed. And after 6 months of being on this molecule called uridine, she's up running around, talking to her mom, picking up a book and saying, "What is this?" "That's your book." "Oh, that's my book." "Okay." And then they visited the lab here just a few weeks ago. So those are some of the things. There are not enough of them. They're not as many as we'd like to see, but it offers some hope.
Yeah. Let's see. Does anybody in the audience have any questions right now? If not, I could ask some of my own. I'll wait and see if anybody has anything. So, oh, someone has one. Do different glycans feature more prominently in certain cells or areas of the body? Also, do the variations of CDG affect different glycans?
The variation in CDG does affect different glycans. I didn't answer the one for pig A deficiency, but there's at least some efforts being made there to try to provide a special molecule that might be able to overcome a pig A deficiency. Now, those studies have not, gotten to the clinical trial stage, but I think there are people who are still working on them. And so there are actually about 8 or 9 different major pathways of glycosylation. So different cells will use, rely more heavily on one of those versus another. So if you have certain things that are very prominent in blood cells, well, those may be most affected by a mutation that affects pathway A or pathway B. It depends on what the specific mutation is, and it can depend on what effect that has on the individual glycans. And I guess part of the problem is there's a huge range of different severities that people with CDG have. And even a patient who may have exactly the same mutation as somebody else, sometimes even the same family, they'll have a different severity. And, you got to imagine that the parents are trying to take care and giving them the best care they can, same diet, same environment, and yet one can be more severe than the other. And those are other genetic or epigenetic factors that come into play. So it can be quite variable.
Yes. And then Shay asks, if treatments work and a cure is found, do you believe that the knowledge would carry over to other illnesses with massive breakthroughs and not just limited to CDGs?
Oh, that's a great question. In science, this is what we always look for. That something that is so fundamental that it not only applies to the thing you, let's say, discovered and the thing that you're working on, but it has great implications for other disorders. And the reason it will is because scientists communicate with each other, they publish articles, and so the entire scientific community can become aware of a discovery. And depending on the individuals, how much they read, how often they go to meetings, how often they talk to their friends, they can hear about or read a paper and then they go, "Oh my God, that has relevance to me. And I don't even work on that disease. I work on something else, but I can see how this would apply." And then they may go off, take that information and apply it to other disorders. And so that's really common. And that's, I guess, if you had to say, what is the tenet of our faith in science? It's that we're all connected. We all are using the same set of blueprints. We don't understand them all. We don't know how God created things, and yet scientists, I think, I look at it this way anyway, respectfully knock on nature's door or God's door, or however you like to look at that. And if we ask the questions in exactly the right way, then we have answers that may be revealed. And we have to do that with a great deal of reverence to be sure we're asking the right question in the right way. And so scientists tend to be skeptical. And that's good, because you want to be so certain. And you can't always be certain. Sometimes you have to take a jump. Like we took a jump of drinking mannose. We thought we'd be all right, and we were. But we had no idea it would apply to so many different things. And even with mannose, there is the possibility that it can be used to treat other kinds of disorders. And I will divert here for just a second.
Of course.
It turns out that mannose, for a completely different reason, is used to treat urinary tract infections.
Really?
Yeah. So you can buy mannose and use it both as a preventive against urinary tract infections, many kinds, not everyone, and a treatment for it. And the reason that it's able to work, as I say, is completely different, but it goes back to basic principles of science. So we know that sugar chains on proteins will bind to other things. So there can be an interaction between a sugar on a protein and maybe another protein. It turns out that the bacteria, one of the most common types of bacteria that cause urinary tract infections, bind onto the cells, the epithelial cells, because they use a sugar chain recognizing protein and bind to the sugar chains on the cells in the urinary tract. But if you take mannose, and it doesn't even require a lot of mannose, if you take some mannose, you excrete it. You don't absorb all of it. You pee some of it out. And there is enough mannose there that it outcompetes the binding of that bacterium onto the cell. And so you wash away the infection. Isn't that amazing?
That's fascinating.
So here you have the same thing that can be used to treat one kind of CDG, and yet it has applications in other ways for totally different reasons. But that's where the basic science comes in and tells you you need to understand this.
Yes. So do you have any thoughts about what the future of the field of studying CDGs and glycobiology looks like going forward?
Yeah, I have some thoughts on that. One of my hopes is that the area of glycobiology is not generally well known in the scientific community. It's getting better, but it's still not, how can I say, a well appreciated and well considered science. And that's why there has been some slow developments, I think, in all of these glycosylation disorders. But clearly, parents are interested. Clearly, physicians who have patients are interested. And so now my hope is that we can bring the knowledge of a lot of these CDGs back into the glycobiology community and interest other glycobiologists to understand and see how their work applies to these disorders. And one of the ways that we've done this over the years is to have a meeting. We're going to have a meeting in San Diego between February 25th to the 27th. And we bring together physicians and scientists and the families. And what's so important about that is that's all the stakeholders. And we have a scientific conference where we're dealing in the highest level science that may have to do with models of the disorders as well as some emerging therapies. But then we make sure that the families can be present at those talks, although they might not understand all the details. They're there to try to absorb it. But then in addition, we have this thing we call the doctor's in session. And at that, we take physicians and scientists around to meet different groups of families and to field questions. And oftentimes these are medical questions, as you might think, coming from the families. But sometimes, just like you're doing here, you're asking pretty sophisticated questions of the scientists. And so now the scientists, many of whom have never seen a patient, who have no contact with things that their work could make a difference in, they put faces on their work. And I can tell you that there are some people who walk away as changed individuals saying, I go back to my lab and now, I see what my work can be used for. I see how it can help. So I'm hoping that one, we attract more glycobiologists. The other side of the coin is true, which is that there are more people who from outside glycobiology will come into the field because, of course, this is my origin. But I look for all the stakeholders in the community, the parents, the patients themselves, physicians, scientists. We're all in this together. And we don't want to be in silos. I've seen the cost of being in silos. That's not good. This is what we need to do. So I have great hopes for the future, especially now because there's some therapies that are coming along. And I suppose one of the things that people always ask about is gene therapy. And it's still, I guess you could say, still in its infancy, but it's beginning to draw a lot more attention. The issue with gene therapy is each individual disorder is a start over from square one. You have to go to the beginning and prove that it's going to be useful, efficacious, and safe. Each gene has to do that. And so it's a very long process. And we have 160 right now CDG genes, and there's not going to be the resources to be able to do all those. Are there going to be for some? There will be. There will be. But at the same time, I think to be honest about this, a lot of the problems that have happened, or a lot of the issues, the clinical problems, were already going and developing before the child was even born.
Yes.
It may not be possible to correct or improve those. On the other hand, there are a bunch of things that are progressive. And because they are progressive, you might stop a condition from worsening if you had a therapy. Retinitis pigmentosa in adults with PMN2 CDG, osteoporosis. So you might be able to do some things with either conventional therapies or potentially even gene therapies, but I think we have to be careful about that.
So would something such as enzyme replacement therapy be more viable as a treatment for CDGs?
Well, that's a really, really good question. If there's any rare disease therapy that has done well, it's enzyme replacement therapy. There are some issues with that I'll mention later, but I think that is one of the things that is a potential. Now, here's the problem. The way enzyme replacement therapy is done currently is it deposits the new enzyme into vesicles that go to the lysosome. Now, if you're treating lysosomal storage disorders, which is what enzyme replacement therapy has been used for, that's exactly where you want it to go, because material accumulates in the lysosome. So if in fact you're putting something in that can go to the lysosome, this is just ideal because it goes to some of the source of the problem. Again, not everything would be corrected, but that's the advantage of it. Many of the kinds of disorders for CDG, because it's in different parts of the cell, can't take advantage of that kind of targeted thing. In other words, for what you're trying to fix, most of the enzyme replacement therapy goes to completely the wrong place. It's not going to help.
Yeah.
So that's where now there are inventive ways that people are trying to take those enzymes and put them into the cytoplasm, not the lysosome. And in the cytoplasm, that means sort of the inner guts of the cell. If you get it there, you might be able to use it. However, the problem in many of these issues is that if it's just the enzyme itself, that's often located within organelles such as the endoplasmic reticulum, or in very large complexes, or in the Golgi. And it's much, much, much more difficult to treat those disorders. So you can imagine some bright lights out there as some possibilities, but it's not gonna, it's not going to be probably the cure-all.
Yes. So you were talking about with the symposium that will be going on in San Diego in February of next year about connecting scientists, doctors, and families. Is there anything that the average person can do to help with these disorders or learn more about them?
Yeah, there is this Frontiers of Congenital Disorders of Glycosylation consortium. And that is a series of 10 different clinical centers, plus the place I'm at, Sanford Burnham Previs in San Diego. If you have a doctor who knows about this organization, and you can find that on the web, then that doctor could actually learn more at a medical specialist level about what's going on. So that's one thing. The other thing I think is really an amazing, really impressive organization here in the US, and that's CDG Care. And CDG Care has, in the last, maybe 7 or 8 years, it has just blossomed. And this is a parents organized organization. It's nonprofit, of course. So people who might want to be involved in CDG, to be cheerleaders, they can make contributions to CDG Care. And I think that's one of the best things that can happen, because they have an outreach to parents, to families that need information. They also, in the last couple of years, have started to award grants to scientists so that they can go investigate certain kinds of CDG in very particular ways. And because there's a scientific review board of scientific advisors as part of CDG Care, you can be sure that if you give some money there, that they're going to review the potential science and reach a consensus about what might be worthwhile investing in. So CDG Care is a really good place to go. And in my own lab, we have a thing we call the Rocket Fund. And that was made for a little boy that we diagnosed a number of years ago. And people over the years have held fundraisers and made donations to our lab so that we can carry on our work. And I think, of course, I think that's important. But I think being able to reach out to multiple different places is very worthwhile. And CDG care is certainly going to be a place that you can depend on.
Yeah, that's kind of what I was trying to accomplish with this charity stream that I'm doing today. We currently have people in the audience from Ireland, Canada, all over the United States.
Now that's great. That's great. We're actually working with one family right now in Brazil, trying to see if we can make one of our therapies useful for one of the patients down there. We're working hard on that. Mom is down there doing everything she can. We have a collaborator in Canada who has reached out and provided some of the material that we need. We have people who have engineered getting things from Canada into Brazil. We worked out a situation where we can have blood samples from this patient analyzed in Brazil, but then also as part of our Frontiers of CDG consortium, have some of those samples sent to the US for analysis. So, if the alarm goes off, if the bat signal goes up in the air, I can tell you we're on it.
Yeah. So, you've been able to help a lot of people in the audience today who don't really have a background in scientific information beyond like a basic high school level a lot of the time, learn more about CDGs and glycobiology. If someone was interested in learning more and studying more about these disorders, do you have any recommendation for someone who doesn't have a strong science background in how they could get started in learning more about CDGs?
Yeah, I would say that probably the best place would be to contact CDG Care because they've produced some documents that are fairly easy to understand. Now, of course, most of the people who come in are actually arriving because they have already an interest because of diagnosis in their family, and so that's an easy way to do it. If people want to write to me, I can probably, if they have specific questions, I can probably give them a good orientation. And I think that CDG Care will also be working at some level to provide new information, general information. In fact, I'm going to be doing for the consortium, I'm going to be doing a little short, I guess you'd almost call it like a cartoon or a graphic novel, talking about biomarkers, why you have them, what they're good for, why it's important for anybody to do this. And so if I find that there are people who have many general specific questions, that's one of the things that we can answer. In addition, there is trying to think of the right way to say this. I guess it really depends on the level of sophistication. And as you said, someone who has maybe a high school level experience. There's also a group in Europe that is working. It just held a world conference on CDG, and they've produced some documents. But again, this is going to be more oriented toward families who already know and suspect they have a diagnosis, rather than people in general public who want to learn more about it. There is a textbook out there, but I think it might be a little bit too advanced, but you can get it on the NCBI, National Center for Biotechnology Information. You can get it on the web, all the different chapters, and it's called Essentials of Glycobiology. That may be a bit sophisticated, but if you write to me, I'll see if I can find some better sources.
Thank you very much. And speaking of, you were saying that for the conference you'll be telling the average person. Oh wait, someone in the chat just has a question. I have a friend who is interested in pursuing medical science in some form, and glycobiology sounds like a field she might be very interested in. What sorts of higher education opportunities might be available to her?
When you say a higher education opportunities, what do you think you're talking about? Starting from where?
There's a delay, so I have to wait for the question to pop up. But I guess it would be like, what sort of major should somebody study?
Okay. So if you're interested in glycobiology, you're one of the select people who see the light and are willing to jump in to the future. And that's what I really see here. I mean, there's a lot of work that's being done in other areas. Glycobiology is absolutely ripe for going forward. And so if you're in high school, got to take your science courses, biology, chemistry, advanced biology. In college, then I think you need to be sure that you're strong in chemistry. Actually, glycobiology started with chemistry, and the biology has become more prominent over the last several decades. But there would be certainly biochemistry, cell biology courses, some physiology courses, but ones that center on the molecular basis of how the cell works, how molecules are moved around within the cells, and how you make glycoproteins. There are not very many places in college, in any of the colleges, that have an undergraduate course in glycobiology. UCSD, University of California, San Diego, where I went, is one of the few places that offers that, but it's not the only place. And again, if somebody is looking for that sort of thing, I can probably help direct a few people there. Then, if you're talking about how about after college, well, then I think you're talking about trying to find a Ph.D. or a master's degree, and those are only going to be available at half a dozen really well-known universities. But that can move you along the way, and because again you're getting so much more integration between physicians and scientists and bringing in families. I know what it does for people in my lab. When the families come in, it's a moment of celebration. I mean, everybody is excited, and it changes lives. I know that. So that would be the details. If someone has questions, wants to write to me, bring them on.
I'll make sure to send them your email after the interview if they're interested.
Okay, sounds good.
Yeah. Although speaking of like people coming to it from different paths, what was your own path like? You mentioned the slime molds kickstarted your interest in it. Did you ever consider pursuing anything else or focusing on another field of research before you found glycobiology?
Oh, I just kind of lucked into glycobiology, I think. I was interested in this one component of the slime mold, and it turned out to be carbohydrate, which is what glycobiology is centered on. And I think the thing that began to get my interest, I suppose, it was realizing that the slime mold had certain parallels to people. And the parallel was that this molecule called mannose-6-phosphate was found on slime mold proteins as well as on human proteins. And it turned out that the deficiency in slime molds of mannose-6-phosphate, because you can isolate mutants from slime molds, had a parallel in a disorder called eye cell disease that is considered a lysosomal storage disorder, but it really is a failure to add mannose-6-phosphate. to proteins, specifically those that go to the lysosome. So what happened is that I began to get interested in looking at this eye cell disease as a way to understand more about the basic science. But as I got more and more exposed to the complexity of eye cell disease, seeing the patients, and of course, having my own sister be disabled, I felt very, very much at home with all of the families and with all the patients. It was like going home again. And I have to say that, and this is back probably in the early 90s, up to maybe mid 90s, because I don't have formal medical training. I was always worried that a physician would come along and say, "Hey boy, you're not qualified. You get out of here. We'll take care of patients." Because I thought, how can I, with my lack of medical training and just being an everyday lab rat, how can I ever think I could help patients? Maybe I'm not qualified. Maybe I can't do anything. Well, at the time, and as I said, it changes, there were very, very few physicians who knew glycobiology, and not even very many scientists. So I had an opening. So as more opportunities came along, there were a few other people, but our lab became sort of a receptacle to field questions from physicians, some scientists, and a bunch of families would come directly to me. And of course, my job was to try to talk to them, but to do it in a way that also then looped in the physicians. So, I had a lot of practice of being able to talk to people who had potential cases and knowing what I might be able to do to help them and help their docs. So I've done a few other things in other aspects of science, but it's always been related back to glycobiology because there's such a sort of an open field ahead.
So you were saying that for the conference that's occurring in February of this upcoming year, you're going to be doing an introduction for people who don't know much about biomarkers. Would you be willing to give us a small sample of what that would be like for the audience?
Yeah, this actually is a little video I'm going to be involved in doing. And the sort of the 1-minute version is, you oftentimes hear about people talking about biomarkers. Well, what are they? Why do you have them? What good are they, and how can I help out? Well, you do biomarkers every day. You don't think about it. But if you take your temperature and you got a fever, well, that's a biomarker. How about if you're breathing hard? That's a biomarker. How about if you have an upset stomach? Well, that's a biomarker. It says something is going wrong and it's amiss. So in CDG, you can have all of those things, but it doesn't necessarily pertain in every way to something so specific to CDG. So what we have to do as scientists and as physicians is to figure out those things that will be the most informative and revealing biomarkers that we can use to help understand, one, what's the severity of the disease? Is there a change of this disease, of this biomarker that we can identify? Is there a change in that biomarker as somebody ages? For instance, maybe it gets better on its own, and it has nothing to do with your improvement clinically, but we think it might. So we have to study that over years. And then finally, if we have the right kind of biomarker, we can use that potentially as an indicator that a therapy may be working, because that's what science involves. And if you're going to put some material, a pill, a treatment out there, you have to know that it improves the lives of the individuals and that it's safe. We found out that mannose was safe, but we had to be very careful because it could have some bad side effects. But I think the most important thing is we can use a biomarker to track a therapy. And so we're always revising and looking for new biomarkers that are as specific as they can be. So if you're a parent who is not sure about what to do for biomarkers, please cooperate and be involved with any study that might suggest that they're going to look at a biomarker, because you're going to help your own child. You're going to help the community. You're going to enrich the science. You're going to be able to give us a good direction to go in. And if we have a false biomarker, the only way we know that is to say, ooh, this isn't working. Okay, we got to go back and we got to start over and look for a new biomarker. And that's always an ongoing scientific process. We look for the best biomarkers we can, and that'll help us understand the natural history of CDGs as well as any potential therapy. Is that helpful?
Yes, very helpful. And Nick in the chat says, do you have any ideas of other areas of research glycobiology research might benefit? You mentioned cancers earlier. Are there other fields?
I'm not sure I understand the question.
Other areas of research glycobiology research might benefit, like studying glycobiology and CDGs might help with understanding more about cancer.
Oh, yeah. Well, there are huge numbers of different places that this could apply. So any kind of neurological disorder, a lot of neurological abnormalities may have a basis in glycosylation. There are some seizure disorders that we know of that you can show are due to very localized mutations in some glycosylation gene. Also, the way individuals will interact with bacteria in the gut is going to be influenced by glycosylation, because the bacteria in your gut actually can be a formula and a readout for your state of health. And the bacteria, believe it or not, like to eat some of the sugars that our gut manufactures. So some of the health there can be involved in having the right sugar balance and understanding how glycosylation is influencing the growth of bacteria in your gut. There are other systems. The kidney, for instance, can be involved in different ways of health that may be influenced by understandings that we've had from glycobiology and some therapies that might even help. For instance, people who have certain kinds of kidney problems can be helped by some of the therapies that are being developed to look at a type of muscular dystrophy. So there are lots and lots and lots of different systems that benefit from glycobiology. And in fact, in this book, Essentials of Glycobiology, that you can get on the NCBI bookshelf, there is a whole chapter devoted to all kinds of different impacts of glycosylation on different organ systems, from the blood to immunology to skin to kidneys to liver.
Yes. Yeah. Nick says thank you. That really helped a lot. The explanation. So we're coming up on the hour mark. We're coming up on the end of our time together. I want to thank you very much for being willing to come on and answer these audience questions. And I was wondering, do you have anything before we go that you'd like to let the audience know about? Any parting words?
Yeah, keep faith in glycobiology. It will work out. We just need to keep funding strong through the federal government. That helps us ask important questions, and it will yield answers. It may not be as fast as we want, but we need the support of Congress, and we need the support of people who understand what we do and know that our head and our hearts are in the right place, but we got to have the resources to do it. So contribute to CDG Care, support those people who believe in science as politicians. And if you get the chance to come by our lab or you want to make a contribution, that's fine too.
Yeah, everybody in the chat right now is saying, please tell Dr. Freeze we all say thank you and that we've learned so much from this, and they think you were very interesting and engaging.
Well, thanks to everybody. And it was a real honor to be here, and I'm glad I could help out just a little bit.
Yeah.
Okay?
Perfect. Thank you very much, sir.
All right. Thank you, Sarah. We'll talk to you later.
Talk to you later.
Good luck.
Thank you. Bye.